In this video, we're going to review how to solve rational equations. In order to solve rational equations, the first step is to eliminate denominators. One way of doing that is to multiply both sides of the equation by the least common denominator. In order for us to find the least common denominator, we're going to factor this expression as much as possible. It looks like the only thing that could be factored is the trinomial in the second fraction. So let's do that. We're looking for two numbers that multiply to give us 6 and add up to 5. The two numbers are 3 and 2. And that's going to be fully factored, which helps us to find the least common denominator. So in this case, the least common denominator looks like it needs to be x plus 2, because x plus 2 is in the first and a second term, but also multiplied by x plus 3 in order to be the common denominator for the second and the term on the other side of the equation. So let's multiply both sides by this least common denominator. First, I'm just going to copy the entire equation and just leave some space for that multiplication. And we're going to multiply each term on both sides. So x multiplied by x plus 2 in brackets times x plus 3. Same for this next term, x plus 2 times x plus 3. And I'll just multiply it on the other side. Doesn't make a difference. Okay, so now let's see how we can simplify this. It should eliminate all the denominators. X plus 2 eliminates x plus 2 in the denominator. The whole least common multiple is gone in the second term, and x plus 3 cancels x plus 3 in the denominator. So let's see what we have left. X plus 3, we'll just put x in front to show the multiplication, and plus 2 equals 2 times x plus 2. No more denominators. So now we have something that we can work with. We can simplify first by expanding to eliminate all the brackets. So we'll get x squared plus 3x plus 2. And on the right hand side, 2x plus 4. Looks like we have a quadratic equation. In order to solve a quadratic equation, we need to bring everything to one side to have a 0 on the other side, and that means we would have to subtract 2x plus 4 from both sides, so subtracting 2x and subtracting 4. So we'll have x squared plus 3x plus 2 minus 2x minus 4. And now collecting like terms, we'll have x squared, 3x minus 2x gives us plus x, and 2 minus 4 gives us minus 2. Now that we have this quadratic, we check first, can we factor this as much as possible? If it's not factorable, we would use a quadratic formula. It looks like this one is possible to factor, so let's do that. We will have x plus 2 times x minus 1. And because the product is equal to 0, we're saying either one of those factors can be 0. So x plus 2 could equal to 0, or x minus 1 could be 0. Solving each individually, we'll have x equals negative 2 or x equals 1. Now, those look like the two solutions, but we need to check if they work. So we need to substitute them back into our equation. Notice if we substitute x equals negative 2, we will be dividing by 0. So x equals negative 2 is called extraneous solution, and it's not part of the solution set. We're only going to have x equals 1 as our solution, and that completes our example.